Okay, this is going to be a quick video about one of the few things that I find cool about conics. There are some cool features about conics. They all have to do with the foci, but we're not talking about that today. We're talking about how to solve conics or get the general form with a few points. So in case you don't know what a conic is, basically it's this equation where a, b, c, d, e, and f are coefficients, and they can be any number. And when you graph them, they'll basically give you a shape that you can get if you take a slice out of like a cone, out of like a sort of weird cone, like two cones placed like that in 3D space. Imagine taking a slice with a 2D plane, and that would be the shapes they give you. Let me show them. You could get either a parabola, a circle, an ellipse, or a hyperbola, which is, now we can find this if we just take like some points. I think at most you need 5. Yeah, at most you need 5. You can get the whole conic. The catch is you need to get some or one or some of the coefficients, and based on how many coefficients you have left, based on how many unknown coefficients you have, that's how many points you're going to need in order to solve it. So I'm going to give a quick example with a circle. Now, in this case, b will equal 0, so we don't have to worry about the complexity that x, y brings. A equals 1 and c equals 1, so we have a circle, and these are our points. Now, finding circles is the easiest type of these problems that you could do, but you could apply this just for anything. So since we know the coefficients of a and c, we put them on the right hand of the equation. So we now have them here. And since we know that it's 1, we just replace it as 1 and we get this. Okay, now all that's left is we plug in the x and y values here into each of these. So we'd get something like, let me turn down my sensitivity. We'd get something like d0 plus e negative 4 plus f1, because there's not really an xy behind that, f1, and y equals 0, negative 4 squared is 16, and negative again, equals negative 16. So we do that for every single one of these. Again, we get something like d2 plus e negative 4. You keep doing that, you get 3. And for some of you, you might know systems of equations, matrices, which is how these are going to be solved. Matrices are really useful when solving systems of equations. So let me give you a quick example of what that's like. Let's say we have 3a and we add 2b, and we know that's gonna be 8. Okay, well then a and b could be anything so long as they add up to 8. But if we also have a and we add 2b, and let's say we get 4, yeah, I think that works out. Yeah. Now we can have an exact evaluation of what a and b are. So we would put the coefficients into a matrix. Let's just put 1 over here, and the matrix will look like this. 1, 2, 2, and if we take the inverse and apply it to what's on the right hand side of the equations, we will get A and B. Typically, you would solve this using Gaussian elimination, and it wouldn't look like that. It would be an extended matrix where you'd have stuff like this line here, and to get what you want there, you have to get it. You have to use Gaussian elimination to turn this into a 1, this into a 1, and these two into zeros. I'll get the identity matrix. So let me do this real quick. So what you would first do is you subtract the bottom one from the top. That would give you 2, 0, 4. We divide this by 2 to just get a 1. So 1, 0 equals 2. So we know that A equals 2. This is looking bad because this sort of looks like a 1. Let's make it like that so it looks a little clearer. Okay, now we take the bottom and subtract this from the bottom, so we'd get a 0, 2 equals 2, and then we just divide by 2 and we get 0, 1, 1. So then it would look like 1, 0, 1, and 2, 1. So the new matrix, when you apply this, oh my god, it would look like 2, 1. So A would equal 2 and B would equal 1. And let's just make sure that that's right. 3 times 2 is 6, 2 times 1 is 2, 6 plus 2 equals 8. So this one works out. 1 times 2 is 2, 2 times 1 is 2, 2 plus 2 is 4. So all of that works out. Now we apply that same logic of systems of equations to the conics. So we don't really care about the shape anymore, we just care how it looks when you plug this in. So remember, it would look like this. The matrices would look like that. Now, I forgot what that arrow was doing there. So yeah, when you plug that in, you get this for the left hand side and this for the right hand side. We take the inverse. I don't really feel like doing that. It's really annoying. One thing that does make it easier is that the f side will always be 1 since you don't have to multiply it by x or y, so you can always find that easily. But you take the inverse and multiply it, or you take the inverse and apply it to the right hand side, which would give you negative 2, 0, and negative 16. Hopefully you're following along with me. I'm not that good at explaining stuff, but so when we apply that to this, that gives us our D. So D will equal negative 2. E, which is 0, and F, which is negative 16. And so the equation, a full equation would look something like this: negative 2x plus 0y minus 16 equals negative x squared plus y squared. If we can rewrite it into the general form as x squared plus y squared minus 2x minus 16 equals 0, and that's how you get your equation. your general form just from 3 points and 3 coefficients. Please tell me how I can improve in explaining. I'm not really good at that, and if you know, they say if you can't explain it, you haven't learned it, something like that. That's all.